Okay, we're now recording. Again, I'll share this recording after I close this. I'll close this around 9:30 tonight, and then I'll upload it and make sure it's to Schoology. So questions were asked about number 18 and 19 from the final exam review guide. So as I mentioned, expect 3 to 4 questions on conics sections, and 18 and 19 are definitely from conics, the first unit that you guys did in January while still on paternity leave. So here you ask you to complete the square process, write this in vertex form. I probably won't ask like a question just like that on the final, but what I will ask is, yeah, here's a parabola, not in standard form, write in standard form, and then tell me all the stuff about it and graph it. So it's a skill you definitely need to know. Here's how you do it. So first off, your formula sheet is going to be your best friend, right? So the formula sheet's right here. Everyone will get it for both parts 1 and part 2. And I did change the pre-calculus, sorry, the parabola one just a little bit. I know I didn't teach conics to you guys, but I like using something called P instead of A. So 4px x minus h equals y minus k squared, that's horizontal parabola, or the other way around, 4py minus k equals x minus h squared. So the fact that our x is squared here, I want to just, the equation look like this, 4p y minus k equals x minus h squared. So I want it to look like that. How am I going to do that? Well, I have y plus 5. I'll move the negative 12 over to the other side to have y plus 17. And I'm going to factor out the 5 from x, 5x squared, and 15x. So that should seem pretty straightforward. So again, all I did is I did a couple things. I moved the negative 12 from right to left, and I pulled out the 5 between 5x squared and 15x. So the goal is to make my equation look like the line up above, right? To make it look like that. Then I can identify the vertex and all the other stuff. Okay, we got 17 people, more than half the class. That's awesome. Anyhow, remember to complete the square, you take half of the linear coefficient, which is 3/2, and then square it to get 9/4. So you gotta take half of this and square it, okay? So now, but what did I really introduce was 45 over 4. That's what I really introduced. Because if I just do the 5 back in, I get back to 5x squared, back to 15x. And then that's a new term I added, that constant 45 over 4. So I'm pretty much done. I will just say the answer is going to be, the right side will be 5 over x plus 3/2, because the whole point is to factor it as a binomial squared, because 3/2 squared is 9/4, and if you were to FOIL, you'll get back to 3x in the middle. And that's kind of weird. 17 is 68 over 4, I believe. Yeah. So that's 113 over 4. And then you could move the 5 over to the other side, make it 1/5. So that's kind of like your 4p value. I mean, I'm not going to give you something this wacky on the final. Those numbers are just way too out of control. But that's how you would get it to look like the standard form of a parabola. So the vertex would be negative 3/2 comma negative 113 over 4, which is kind of weird. And then your P represents the distance between the vertex and the focus. P would be kind of a weird number here, but again, I'll give you something that's really straightforward. But that's how you do the completed square process, especially when the leading coefficient of the quadratic is not 1. You pull the 5 out and then take half of the linear coefficient squared and add to both sides. 19, definitely you're going to see something like that.
Yeah, wait. I knew how to do it, but when I was looking at the
19,
the answer sheet, yeah, for 19,
Mhm.
there was a way that you plugged in something, but I couldn't understand what equation
Okay, well,
you're
let's take a look.
putting in.
Okay, here we go. Actually, yeah, let me walk you guys through the solution. So the way this will be designed, it'll be designed in such a way where something should cancel out very nicely. So I see 4y squared in the first equation, 2y squared in the second equation. So I'm going to multiply the second equation by 2. By doing that, that enables me to subtract the equations and cancel out the y squares, or 4y squares in this case. So I multiply the second equation by 2. So that makes sense, Anthony, how I did that?
Yeah, but I was just talking about like the ending. Yeah,
Okay,
right
good.
there.
Yes, right
that
here.
last part. Yeah.
So I factored out 25 and then factored. So I got two answers, 4 and 2, right? So that means that x equals 4 and x equals 2. So then I plug in 4 and 2 back into one of the other equations, into the first or second one. Probably the second one's probably easier.
Okay.
So I threw it back into the second one and solved for y. That's what I did.
Okay.
Just like you would for any system of equations. You plug it
Yeah.
back into one of the original equations, solve for the variable. And then if you think about it, second equation is a parabola. The first equation, I think, is an ellipse. And they're intersecting twice, or sorry, 3 times. So I guess it would kind of look like that. So, oh, someone just left us. That's okay. So yeah, so that's how it goes. I mean, if I could do it from scratch if you guys want me to. It's really simple. Just multiply this one by 2. So it becomes this 4y squared. And up top, I'll repeat it. I'll kind of rearrange it so things line up nicely.
I don't think you multiplied the 25x and 50 by 2.
Oh, I forgot to do that. Yeah, no, I did it on the solution key. Yeah, sorry about that. Yeah, no, I did it on the solution key. Yeah. Let me do it again. Sorry. Thank you for correcting me there. And then someone's saying 22, 25. Thank you, Gigi. And then Ainsley 31. Okay. And then also I know Charlotte asked about transformation. So I'll get to those after I finish over 19 really quickly. And 35 for sure. No problem, Claire. Yeah, so sorry, let me read this again. So multiplies by 2. So it's going to be 4y squared negative 50x. There it goes. So much better now. Plus 100 equals 0. And the top one, I'll just rearrange so they stack nicely. And then you want to subtract these equations, right? So again, I'll just work this out in all its glory. 4y squared cancel. Negative 200 minus negative 50 is negative 150x. 300 minus 100 is 200. And of course, plus 25x squared. And I trust you guys should be fine with the factoring. That's a skill that you guys have done for a while now. X squared minus 6x plus 8. X minus 4, x minus 2. X equals 4 or 2, so super easy, right? And then plugging 4 and 2 back into one of the equations. Probably easier to plug it back into the second equation. Solve for y. I know you guys can do that, and you guys should be fine at that point. Shouldn't be that hard. And if I go back to the solution key one more time, when I do that, I get 2y squared equals 50, y squared is 25, y is plus minus 5. That is associated with x equals 4. Plug in the other one here, I get 2y squared equals 0, y is 0. That's associated with x equals 2. So there we go. All right, so now transformations. I know you asked about that, Charlotte. So that's a skill that you do need to know. Oh, there we go. Let's look at 17. Perfect. That's a perfect question. We had that on one of our tests, and something like that, expect something like that on the final exam too. So here you're asked to write the equation with absolute value. Absolute value is obviously this. That's your parent function, right? That's the most basic absolute value you can have. And we're supposed to do some things. We're supposed to vertically stretch by a factor of 4, reflect over the x-axis, and then move right 2 units. So that means that, generally speaking, I'm looking at something like this. So guess what? A is 4. That's a vertical stretch. Reflecting over the x-axis, well, now I'm going to change that, make it a equals negative 4. So let me get a highlighter that might be a little better. So a is negative 4. And moving right 2 units, h is 2. You didn't move vertically up or down, so k is 0. So y equals negative 4, x plus 2, sorry, x minus 2, and that's that. So that's a good way of assessing transformations because, yeah, you should know how to build a function based on whatever transformations I tell you are happening. So that's all. That's one question on transformations that
Mr. E,
you could see. Yeah, go try it.
why would the 2 not be on the outside?
That would be a vertical shift.
Okay.
Because think about if you were to plug in numbers like y equals outside of x, right? make a quick table. 0, 0, 1, 1, negative 1, 1. If I have y equals absolute of x plus 1, if I plug in the same x coordinates, 0, 1, negative 1, and then calculate y, all the y values are going to go up by 1 now. Hence, that's why the outside the vertical shift, not a horizontal shift. So it's always on the inside. Sorry, it's always on vertical shifts are always on the outside. Oh, why is it turning negative 4? That's because you vertically stretched. So it's kind of like a slope in a way. It gets steeper. And then reflecting over the x-axis means now the graph's below the x-axis. So all the y values go from positive to negative. That's why you need a negative on the outside to multiply by a negative. That's what it goes. If you're reflecting over the y-axis, then negative goes on the inside. Because then you want negative x coordinates to counteract it. Let's see if we see something else on transformation before I get to Gigi and Claire's and Ansley's questions. Let's see here. Transformations. Let's go back to the bottom. Yeah, there we go. 47's a good one. Go ahead.
Sorry, I was gonna say, do we have a special schedule tomorrow for the
No,
test? Or...
it's normal. No, just normal A through D. Just I'll see you guys C period right after lunch. But I did a B period class, so once B period's over, I'll rush to the cafeteria, get my lunch. I'll be back in our classroom if you guys have questions.
Okay.
And I'll probably start the test probably 5 minutes into the period, like if there's any burning questions at the end, rearrange the desks. And then then after I know after finally you guys were kind of a little bit of a daze, so you might need about 10 minutes before you move on to your next class. So that way I'll and hopefully you don't have a, God forbid, we have a fire drill or anything like that. But just give us some buffers there. So I'll start us within 5 minutes of the period.
Mr.
Yeah, go ahead.
Do you know if the seniors have to go to class if they don't have a final?
Great question. Dr. Whitcomb said something on that. Let's look it up right now. Whitcomb.
Also, Mr. E, I have time and a half, but
Okay.
the Naval Academy doesn't let me
Sure.
use my testing. Like I have to take it in the classroom.
Sure.
I have D period free. So how does that work?
You can spill into it. That's fine.
Okay, amazing.
That's no problem. Yeah, sure.
Okay.
No problem. Yeah, it says right here. So I think Iris, you just asked that question. Yeah, if you teach a class with only seniors and your class does not have a final exam, you may cancel class. So you may need to check with your teacher. So, like for example, if you have like say an English class that's all seniors, or
Wait.
What does he look like?
It's really funny.
Oh, Stella, do you mind muting
I
yourself,
think he-
please?
Give me.
Yeah, that's awkward for you, Estella. You're good though.
Yeah, can you please mute yourself? Thanks. Unless you have a question, that's totally fine. Yeah, so that I think that's the case. Or if you teach classes to non-seniors and not having a final exam, you may not cancel. Well, obviously I'm not canceling class because you have a final. And then if you have a class made up of at least 50% senior having a final exam, the entire class may take a final exam during, which is kind of us. Well, actually, we had a slight exception because we didn't have at least 50% seniors, but I got us approval for that. So yeah, if it's a senior only class, you may skip that class. I mean, but find out from your teacher. I don't know. So anyway, so now let's go back to let's just delete those. Okay, so let's do one more thing on transformations, and then we will get to the other questions that were in the chat. So let's take a look at 47. It's another good transformation problem. Here, just ask, hey, just describe what's going on, right? So yeah, clearly going 4 right. Clearly doing a vertical stretch by 2. By a factor of 2. I mean, if you say by 2, it's fine, but it doesn't hurt to be more precise, The negative does mean reflect, so it goes below the x-axis. Remember, like y equals negative x squared. You guys know that. That's a graph that points down. So that's a reflection about the x-axis. Don't say just reflect. That's vague. Be more clear than that. And of course, 5 up. The order does matter too, because if you were to actually shift 5 up before vertically stretching, the graph would be off. And how do you know the order? It's all about PEMDAS, order of operations, right? You guys know PEMDAS. So P is like the parentheses. The absolute value is kind of like your parentheses. And what's the first thing that we see? The -4. That's responsible for shifting 4 right. Then what comes next in order of operations? Exponents. We don't have exponents. Multiply. I do have a multiply. -2. -2 is responsible for the vertical stretch and the reflection. I gotta say those next. Which one you say between those two is interchangeable though. If you said reflect, then vertical stretch, that's fine. And then +5 is last because we add, after we do all the other stuff in the order of operations. So the order would matter too, just so you know. So it's +2 instead of -2. Yeah, you say vertical stretch. Yeah, if there was no negative, then you say vertical stretch. You don't have to say reflect. Exactly. So that's another one, transformation. We can do more on this.
Wait, sorry. If there's no negative, then it's just
stretch, just vertical stretch, no reflection, right? The reflect, because the negative makes all the y values negative afterwards, because it causes things to point down instead of point up. So just think about numerically what's happening. All right. So now, thank you for your patience. For the ones who have questions, can you go over stretch and shrink? Yeah, I'll do that in a little while, Gigi. But just going in order. So now Gigi asked about 22 and 25. Let's do that. And then Ains will get to 31, and then Claire will get to 35. So let's do 22, 25. Let's take care of that. 22 and 25. And again, I'm recording, so you guys could always kind of fast forward. If you want to watch, please don't stay up late tonight. I will be very straight with you guys. You might feel a little nervous. That's fine. You're human. I went back to school a few years ago to get another degree, and when I was taking tests, I was like, "What the heck's wrong? Why am I feeling nervous?" Like, like my 40s, and I had a teacher. But yeah, it's human. That's fine. But I would do well if I got to sleep and I ate well, right? So make sure you sleep and eat well. So so we're not staying up late tonight. But if you want to watch something tomorrow morning, or we have a free period, and like there's something you forgot about, like maybe 22, you want to. Well, I forgot what Mr. said about 22. Yeah, you'll have the video. I'll post it to Schoology, and you can. It'll be in the updates. It'll also be in the YouTube playlist. I'll put it in the Final Exam Review folder as well, and I'll email it to you guys. So you guys have lots of ways of accessing it. 22. Here we go. Helps up draw, and I will provide the coordinate plane just so you have that at your disposal. So 9, -6 is like roughly over here, right? 3, 2 is roughly over here. Let me connect those dots. That's your diameter. So your circle kind of looks like this, right? So the question is, how do we find the length of that diameter? Well, your formula sheet will have distance formula on it, I believe. No, it does not, actually. But you don't need it. And here's just why. It's a skill set. Just draw a right triangle. How long is that vertical leg, guys? From 2 to -6. How long is that? 8, right?
8.
Good. How horizontally, it's pretty obvious. So 3 and 9 is 6. Kind of the difference in the x is difference in the y's. And Pythagorean theorem, 6 squared plus 8 squared. 36 plus 64, you get 100. Root it, you get 10. So your diameter would be all this here. D squared would equal all that junk. So your D is just 10. If your D is 10, your radius is clearly 5. And then the center of the circle is that halfway point between these. If you use some intuition, half between 9 and 6 is 3. Sorry, half between 9 and 3 is 6. Half between -6 and 2 is -2. So it's x minus 6 squared plus y plus 2 squared equals 25. And don't worry, I do give you the formula for equation of a circle. It is on your formula sheet. Everything about conics will be on your formula sheet, and it's right here. X minus a squared plus y minus k squared equals r squared. H and k is the center. R is the radius. So that's how you do it. And the solution key should show that too. So yeah, that's all for 22. Any questions on 22 before I move on to 25? You can use this formula.
What are you looking for? You're looking for the radius
In the center. That's it.
in the center.
Yeah.
Okay.
Wait, I'm a bit confused where we got -6 and +2 from. If you go that again.
Oh, that's just the center, the midpoint. Your center is always going to be halfway between the two endpoints, right? And so think about it. What's halfway between 9 and 3? Or the average? put it that way. What's the average of 9 and 3? 6, right? 9 plus 3 divided by 2. And like goes to -6 and 2. If you add that up and divide by 2, -6 plus 2 is -4. Half that's -2. Or just find what's half between 3 and 9, right? It's a distance of 6. Half of 6 is 3. So you got to go 3 away from either end, right? Or -6 and 2, that's a difference of 8, right? And half of that is 4. So you got to go 4 away from either endpoint. That's all. You don't have to make it too formulaic. Yes, you could use the distance formula, which I know you guys learned this and it's a plug and chug, but I actually absolutely despise it because it forces people to memorize and then oh, I don't know distance point. I don't know. I'm like, no, you know the concept. You know how to a coordinate plane works. You know Pythagorean theorem. Just do that. You never forget. I forget this. I'll be honest with you guys. I forget it, but I never forget how to do this because I understand the process, right? If you understand the process, you're all set. I mean, sure, you can do that if you want, but I just don't think it's terribly efficient. I think it's just better just to draw and use Pythagorean theorem, and you get the answer way more quickly, and you don't deal with this messy formula. So, but you could if you want. 25. All right. Ooh, that's a good one. So I do give you the equation of ellipse. Your formula sheet's right here. So and the A and B are kind of interchangeable. I mean, obviously, it looks like it's bigger horizontally, so I'll use the a squared or x squared. So x squared over a squared plus y squared b squared. And this question is quite vague. It's not gonna be this vague on the final, just don't worry about that. But we do see the major axis is 10. So a is 5. And the center is at 0, 0, because you're told that. So it's x squared 25 plus y squared over 16. Because you're going 4 up, 4 down, right? Because your b value is going to be 4. So that should be really easy for part A. Part B was really weird. It's just so vague the way the question is being asked. And we've never done geometric probability, so don't worry about that. But players going to double point the dart lands outside the interior angle. So I guess what they're talking about is this area. The whole double points is totally, I think, irrelevant, to be honest with you. I think really what you just want to find is the length of the rectangle. So we know, so the 4.8 is a little tricky, but I'm guessing they're saying this is 4.8 and that's 4.8. So if you have a rectangle, I believe they're saying this is 9.6 and they want this. I think that's what the question is asking. Actually, I'll call it Y since it's vertical. So in order to find that, you're gonna have your equation for part A, x squared over 25, and there's another question in the chat. I'll get there in a sec. Yeah, just plug in 4 in for, because you know the x coordinate is 4.8. You don't know the y coordinate, so plug in 4.8 for x. Solve for y, which is just do some algebra, and you get the y coordinate at that point, and then double it to get the height of the rectangle. So I'm guessing that's what it's asking. Yeah, is there a question like part B? No. So the answer is so clear, don't worry about it. No, there's not gonna be a question like that. I mean, to be honest, the conic section questions are going to be more like, and Leigh, I got your question, Omar, I got your question too. It's going to be more like something like this one, like 23, right? So that's what we're going to be asking. And all this other crap here, like we reduced all the stuff we're going to ask in the table. We're going to try to make it more relevant. Like we never did last rectum. There's no directrix associated with ellipses, so don't worry about that. It's going to be stuff that will be relevant. And we'll come back to that later, but let me get some other questions. Just so some people do want to staff after the questions answered, not waiting too long. Okay, so Ainsley asked about 31. Let's look at 31. And then 35 clear. Let's look at 31. And again, if questions come out, you can put in the chat or speak in your microphone, or if as I'm doing something's kind of confusing, please let me know. All right, it's 31. Okay, good question. So definitely be asking something like that. I am going to give you a factor, just so you know. I am going to give you a factor, so don't worry. Not going to get something like this crazy, but let me walk you through it. So the degree is clearly 6. Maximum extremum is 5. Possible rational zeros. Technically speaking, there is no constant here. So if you said that, I would give you full credit, because you're not wrong. So yeah, you would not be wrong if you said that. But here's what I do to find, if you want to write in factored form, you want to find the other zeros. If you see an opportunity to factor, you should. So you have this now.
Wait, just to clarify, this is on Wednesday, right? Like a polynomial like this.
Yeah, because I don't want to graph and calculator, right? This would definitely be Wednesday, yeah.
Okay, thank you.
Minus 20. Okay. So clearly 0 is an x-intercept, and it's happening twice, which will be a bounce. Now, this part right here, again, I would give you an x-intercept or a factor you can use to break it down. Now, in this case, you probably do want to use, I mean, if this is what you're presented with, you would want to find the possible rational zeros and test them out. So in this case, you could write, even though if you wrote plus minus 0, I'd give you credit, I mean, just 0, I'd give you credit for that. But in order to do this problem, we do need to test some possible rational zeros. So here we go. That's why I'm just going to cheat and look at the answer key. Trust me, I'm going to give you guys something. Don't worry about it. But I'll just cheat. I think when I did this, I was a little frustrated, but I think I did it like 3 or 4 times, if I'm not mistaken. Yeah, -4. Here we go. I'll give you something. Again, don't worry about it. So say I gave you x plus 4. There you go.
And how do you know to use -4? Do you just have to
I'm
test?
gonna give it to you.
Okay. And
Yeah.
the 0, how do you know like the 0 bounces twice or it bounces?
It's even. It's even. When it's
The
odd, it
max-
crosses. When it bounces, when it's even, it bounces.
Yeah, okay. So, and you know, like, how do you get that 0? Where
Oh,
is the
because I
zero?
factor it out.
Oh, okay, okay.
Because if x squared equals 0, x is 0.
Okay, yeah.
That's how we find the x-intercepts or the zeros when you set each factor equal to 0. So in this case, I get x cubed minus 7x squared plus 11x minus 5. And again, I have x plus 4 now. And of course, you have x squared. And I suspect maybe 5. I don't know. Let me just look at the answer key.
And
again,
will you give us that? Will you give us?
yeah,
the
I'm not gonna make you guys do guess and check.
Okay, because I had to do it on the last one. That sucked.
Yeah. Let's see here. If you do 5, yeah, bring the 1 down. That's 5. That's -2. That's -10. That's 1. That's 5 is 0. And then you could factor after that. That's x squared minus 2x plus 1. So you get x minus 1 squared. So definitely you have -4 as a factor. Definitely have 5. Sorry, -4 is 0, 5 is 0, and also 1. The multiplicity of -4 and 5 are once. So those cross. And the multiplicity of 1, of course, is twice. Because from x minus 1 squared, that's a bounce. Now, let's put all this together. Let's talk about the graphing part. And again, I promise you, it's not going to be that crazy. It's not going to be x to the 6th power. And I'm going to give you a 0. Don't worry about it. I'll give you a 0. I mean, or a factor or something that you can easily just lasso that.
And so if you give us a 0, like let's say you give us -4, and we do synthetic division, how do we know what number to use next?
It's going to come down to a quadratic, I promise you.
So you have to do a quadratic and then one of the
and it's something you're going to factor. It's going to be real easy. It's not going to be as crazy as this one here. This one's just insane.
And if you use quadratic and you get 2 x's, do you plug in both of them differently? Like
Well, what happens? You'll get a quadratic that you'll be able to factor, or you can use quad form if you want. But if you use quad form, you'll get the answer will come out nice and neat, like a nice integer or fraction.
Okay.
Yeah, it'll come out nice and neat.
Could you
Are we?
explain how you know whether it's like whether the multiplicity is once or twice?
Oh, because when the factor shows up more than once, I had x squared minus 2x plus 1. My factor had x minus 1 squared. That squared means twice. Or I factored on x squared. That squared means twice.
But how did you know that -4 was once?
Because it only happened once when I did my synthetic division. There was no other. I didn't have to do it a second time.
Okay.
If you don't have to do it a second time with the synthetic division, that's once. Or when you factor it out and there's a square next to the factor, then that's twice. Or if you factor, or if when you factor something out and it's just one time, then it's one time.
Okay.
And someone asked tomorrow what we're doing. Tomorrow doing the graph and calculator part, and I hope I hopefully I made that clear. Let's see. Yeah. Yeah. Is it? Oh wait. Oh my goodness. Hold on. Jesus Christ. Geez, let me fix this. Sorry about that, guys. It's graph and calculator tomorrow. I mean, I did say in class, but yeah. Let me just let me fix the next one. I'm at it. Okay, so clear up that question. Okay, let's keep moving. Let's finish up that problem. Sorry, guys. So when I do the graph, and actually the end behavior, and remember, you guys have to write the limit notation. I know some of you guys didn't do that, but I did talk about it. It's all the notes, all my video lessons. I did talk about it, and everything I do assess, I have talked about in class. Everything's fair. Anything I talk about in class or notes is fair game. So remember, you have to write limit notation. Limit x approaches infinity of f of x. It's pointing up because of the even exponent and the positive leading coefficient. So you have that. And of course, limit x approaches negative infinity, right? Positive right there. F of x will be also positive infinity. So there's an end behavior. So when I do the graph, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, and I'll give you a coordinate plane you can use. So yeah, -4, 5, 0, and 1. So it's going to do this. It's going to hit 0, but bounce off of it. Also bounce off the 1 and do that. How low it dips, I don't really know. You'd have to use calculus to do that. There's not a calculus class. Don't worry about it. But that'd be your graph. Okay, so that's 31.
Wait, how do we know the end behavior? Like, how do we know the?
Because of the even degree. Look at the leading term.
So if it's even degree, it's facing up.
Yeah, both are pointing up. I mean, because think about it, if you're plugging like a positive number for x, overall y is gonna be positive because it's x of 6 is more dominant than the other terms below it. And likely you're plugging a negative number because if you raise a negative number to an even exponent, that's just going to get more positive also.
So you would write f of x,
yeah,
positive infinity, positive.
Yep. Right here, yep, exactly.
And how come the bottom one is f of x equals positive infinity, x equals
negative? Because if x is going to the left, it's still plugged up.
Okay, and then max number of extrema is always one less than the
degree. Yeah.
degree. Okay.
Yeah, and actually, if we do a quick count, we have 1, 2, 3, 4. Yeah, we do have 5 extrema here. We do have 5 relative minima or maxima. 1, 2, 3, 4, 5. Yep. It's like turning points. Okay, let me get to and again, we can come back to this or do more stuff later, but I want to make sure I am being equitable with people's questions. So then, so Ainsley took care of your question, Judy took care of your question. Claire, you have a question about 35, and then Omar, I know you got a question about 33. Let's take a look at 35. Okay, average rate change, yes. So this formula I'm not providing if I do ask it. All it really is just a slope. That's all it is. It's just going to be f of -1 minus f of -4. That's a change in y, of course, right? Over to change in x, which is clearly just -1 minus -4. So your bottom is 3. That's easy. And just plug in -1 and -4. This will be in the calculator portion. So you can see something like this tomorrow.
Is there a difference if you did f of -4
Nope.
minus f of
Nope.
-1? Okay.
But you better switch the x's though.
Okay.
Right? Just like slope in general, right? Same thing, right? No, there's no difference at all. But what's happening here is that this is a funky curve, right? Like we know the end behavior is going to be like this, and it's probably going to do something kind of wavy, kind of like that, you know? And if I were to locate -4, maybe -4 is over here, and locate -1, maybe -1's over here, you find the slope of the line that passes to those 2 points. That's the average rate change. And these are things you're going to see in the first couple of weeks in calculus. So that's why I'm spending time talking about this. And we did in class, you know, but we did it. I think the unit before. I can't remember. So anyway, just plug in your calculator. I know you guys can do that. I'm not worried about it. I'll just show you the solution key at this point, just in the interest of time. But that's the setup. Yeah, here we go. And yeah, I just plugged in my calculator and I got -570 up top, 3 down below, -190. So that's just the slope of the line that passes those 2 points in the curve. That's all it is. Another that's going to be similar to that problem is find the difference quotient. That formula I do give. And it's on the formula sheet, but it's actually going to be next to the question itself. And let me just locate where heck that one is. Difference quotients. And difference quotients, a very big deal because you do it like for pretty much the first 2 or 3 weeks of calculus. Like it's something you do often. Shoot, where is it? I know it's here.
It's number 33.
Ah, hilarious. That was Omar's question, right? That was too funny. There we go. Thank you. Yeah. And Elle's asking, are we getting your formula key on the test with the P, or I'm doing the P, not the 1 over 4A. I'm doing the P for the proud because 1 over 4A is just seems too weird to me. That's not how I teach it. I know you guys may have learned it a little differently, but I think the 4P is cleaner, and we can do another one like it so you can see how that goes. And Leah, I know I will get to your question after 33. I know you're asked about 7 and 13. So yeah, for 33. I will give you the formula. Difference quotient is this. And the formula I'll give you, the equation that you have to do it for won't be quite as long as this one. And again, why do I care about this? Because you do this a lot in calculus. It is a big, I know you're going to probably forget after 3 months, but hopefully it kind of jogs me. Oh yeah, I remember doing this for the final exam. I remember doing this, in the spring mysteries class. So yeah, it's a big part of calculus. It helps help you understand how a derivative works. So anyway, you're gonna replace x with x plus h. So it's instead of 2x squared is 2x plus h squared plus 3x plus h minus 5. So that's gonna be let me get a highlighter here. Right, that's all this. And then minus f of x, which I'm going to put in parentheses just to protect it, 2x squared plus 3x minus 5. That's all this right here. And of course, divided by h. At this point, it's all algebra. You just FOIL, right? Like 2x plus h times x plus h plus 3x plus 3h. Don't just make sure you do care of -5 minus 2x squared minus 3x plus 5 all over h. The x plus h can actually, I'll just do it right now, the foiling. That's x squared plus 2hx plus h squared. If you distribute, you should get 2x squared plus 4hx. And you will not like doing this in calculus, I can assure you that. And there's actually an easier way for doing this type of process, but this is how you learn derivatives. You do it this way, you get a deeper understanding how derivatives work, because that's a big part of calculus in the fall, all over h, and then things should cancel out nicely. Anything that doesn't have an x must cancel. 2x squares cancel, 3x's cancel, 5's cancel. So you have 1, 2, 3 terms left here, which all of them have h in common. So let me erase what's up top. Factor on h. That's 4x plus 2h plus 3 all over h. H's cancel, and that's your answer, 4x. And the significance of it, I'm not going to get into it. I mean, that's going to, you learn in calculus, but I'll tell you right now, you're going to want to take a limit of this as h approaches 0. That's what you do when you get to calculus. And that's called a derivative, in case you're curious. But for now, it's just more the mechanics I care about, what you have to do, go through the motions. So that's 33. And it's not hard, it's very straightforward. And I'm telling you, you're going to see either that or average rate of change. So, and I'll give the difference quotient, it's not hard. 7 and 13, okay, so later ask about that. Ooh, good one. Yes, I will ask a rational function. That's me on day 2 or part 2. Now, I'm not going to give you one like this one because we did talk about how to identify we did talk about whether there's a slant asymptote or not. We never talked about how to find one. So that's why I'm not going to give you one like this, a graph. But there will be a slant asymptote, and in order to graph it properly, you do need to know what that slant, how to find it, which requires either long division or synthetic division. I'm actually not going to do this problem. I mean, what I'll do at the very least is I'll fill out the stuff in the table and leave it at that. And I'll do another one that's similar because I want to do one that's more relevant. But I know I can factor on x. So
Wait,
x squared.
We'll need to fill in the slant asymptote box on the test?
No. You'll just need to say if one doesn't exist, just say none, just like we had in our last test.
Okay.
Yeah.
So wait, how do we know if it exists? Will it just be none or?
Well, so whenever the top has higher exponent than the bottom, that's how you know it exists. Otherwise, it doesn't exist. There will be a horizontal asymptote instead, because you don't have both horizontal and slant asymptote. They're mutually exclusive. It's remember there's that generalization, right? Like, and we talked about this, right? Like, if you have x to the m over x to the n, there's an a and a b plus dot 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 plus dot dot dot. If m is less than n, gosh, it's terrible looking m there. If m is less than n, the horizontal asymptote is y equals 0. If m equals n, there's y equals a over b. And if m is greater than n, then there's no horizontal asymptote. Instead, there's a slant asymptote.
Okay, so will we know just by looking at x cubed minus 4x squared that that there will be a slant asymptote?
Yeah, because the degree of the top is 3, the degree of the bottom is 2.
So would you just say yes to slant asymptote?
Yes, but I'm not going to ask the specific question here because I haven't taught you guys how to find it.
Right, so we don't have to put
right.
So, yes or no?
Exactly, yes. 100%
Okay,
correct.
okay.
Yes.
So then horizontal asymptote, you would say like not applicable.
Right, exactly,
Okay.
for this one.
Right.
So let's come back to the problem here, find the intercepts, and then I noticed some more questions in the chat, so I'll get to those in just a little bit. And maybe it's regarding this, but let me just at least find the intercepts here. So the top is x minus 3 and x minus 1. The bottom is x minus 2 and x plus 1. So the x-intercepts, of course, 0. But you got to write as coordinates, right? So remember, some of you guys lost points to that. Got to write as coordinates. 0, 0, 3, 0, and 1, 0. And the vertical asymptote, of course, is x equals 2 and x equals -1. Got to write as equations. The y-intercept, plug in 0, you get 0. So 0, 0. There is no horizontal asymptote, obviously. Yes, there is that. Holes are when vectors cross off. I never taught you guys how to graph holes, so don't worry about that. But you should know how to identify. We did have that on our last test. If any factors cross off, that gives rise to a hole. No factors cross off, so we say none. And your domain obviously would be whatever makes the bottom 0, you want to exclude it.
Mystery.
There you go. Yep.
If there was a hole, how would you write it, like in the little text thingy?
Well, if there were one, like for example, let's say it's x plus 1, those cross off, right?
Yeah.
Then -1 would be the x coordinate of the hole.
Okay.
And then the y coordinate of the hole, you plug -1 into the simplified form.
Okay.
To get the y coordinate of the hole. It's not that hard. We just never practiced that. So that's why I'm not going to ask that.
Okay.
Okay, but let's look at 13.
A question like that's on Wednesday, not tomorrow.
Right, on the graphic.
Okay.
Okay, let's look at 13 because 13 is a really good one on conics. But let me look at the question in the chat because I want to see what people are asking. Okay, so Charles asked about 39, Anthony about 29, Luke about 35, and then Damon composites. I think it's probably elsewhere. Okay, so I'll get to those in a little bit. So Luke, I just did 35 actually. You may have just showed up. But I'll do it again. But I just want to go in order. What's 35 about? Yeah, I'll go over 35. I mean, just really quickly, the formula is this, but I do need to do 13 because that's a good one. You do f of -4 minus f of -1 over -4 minus -1. Or you could do it the other way around. F of -1 minus f of -4. And it's just going to be the slope between 2 points on a curve. And the curve's right here. So if the curve looks kind of funky like this, you find the slope between 2 points. So yeah, let's talk about 13 because that's a good one. That's going back to conics again. So 13 you can see tomorrow. I'm okay if you guys have a calculator for this. Just so you don't get flustered with any of the numbers here. So first, you have to identify what type of conic section it is. You have 2 squared terms, so it's not a parabola. But one of them is negative. So if one of them is negative, it's going to be a hyperbola. Because hyperbola is something squared minus something else squared. Okay, so let's do it. X squared minus 2x, -9 squared, plus 36y. And I'll move the 71 over to the other side. So this is definitely hyperbola. Now you have to do completing the square. So what I'm going to do is I'm going to say x squared minus 2x. Factor out -9 between these two because it's easy to complete the square when the leading term has a coefficient of 1. Now what I'm going to do is I'm going to take half of the linear coefficient and square it. Half -2 is -1, that square is 1. Half of 4 is 2, that squared is 4. So you add 1, however, you do not add 4 to the right, so you add -36. Reason why is because what you really introduced was -36. You put -9 back in. Because you have to guarantee that if you put -9 back in, you get back to the original form. But because now there's a -36, I better put -36 on the other side to keep it balanced. And the whole point is a factor, right? X minus 1 squared minus 9y plus 2 squared equals 36. Divide everything by 36. X minus 1 squared over 36 minus y plus 2 squared over 4 equals 1. Let me write that in red so it shows up a little better. So that's a parentheses there. So now I know my center. My center is at 1, -2. Because you have to compare it to the standard form. Standard form I already have down here. I don't feel like writing it. If you did on the final, totally fine. Just draw an arrow and point towards it. Now let's do a drawing. By the way, directrix doesn't apply to hyperbolas. I'm not gonna ask about last rectum. I'm not gonna ask about axis symmetry. But let's do a quick sketch. -1, -2 is right here. And your A is gonna be 6. And your B is gonna be 2. So you gotta go 6 left, 6 right, 2 up, 2 down. That's how you have to read that, just like you would for an ellipse. So that will be 7 and -5, 2 up and 2 down. So you wind up drawing a box or a central rectangle. And you draw these asymptotes like this, the diagonals, and then you draw your curve. And because it's x squares being positive, then it opens left and right. If it's y squared being positive, it opens up and down. And fortunately, your formula sheet tells you how to draw it. As long as you get in standard form, your formula sheet's right here. And it shows you how to draw it right there. It's a horizontal hyperbola.
And how do we know it's a horizontal hyperbola?
Because x squared is positive. That should be intuitive. Hopefully it's intuitive. Y squared is positive, and it's opening up and down.
Oh, yeah, okay.
And again, it's right there. And then c squared equals a squared plus b squared will be how you find the foci. The foci is going to be something you're adding to the center. But because it's opening left and right, you're going to be adding it to the x coordinates. The foci is always on the major axis for both ellipse or hyperbola. So in this case, if I do c squared equals 36 plus 4, c squared is 40, c is root 40. Which, by the way, is 2 root 10 if you want to do it that way. So you have to add root 10 to the x coordinate in the center. Sorry, 2 root 10. Comma, -2. And I know you guys did this in January. I know it's been a while, so we're just reviewing, right? The vertices is going to be 6 away from the center. That's pretty obvious. It's at -5, 2. Sorry, -5, -2. And 7, -2. Co-vertices don't worry about because there's no points. I mean, yes, you could think of those as the co-vertices, but that's only reserved for ellipses. I'm not going to ask to find the asymptotes. It's not hard. It's just the slope is obviously up to right 6. So your slope's 1/3 or -1/3, and it passes through the center. So you can write in point slope form, but I'm not going to ask that. And I think that's enough. That's as dissected as we would get it. I will ask the length of the major axis, which of course is 12, and the minor axis, which of course is 4. But again, it's not hard.
Sorry, and how does the 71 turn to 36?
When I completed the square, I had to add 1 and -36. So when I completed the square, well, I mean, I did so much, so I can't really, it will take forever to back up. Just do it really quick. I'll just show you the solution case, but that's easier. So when you complete the square, you take half -2, which is -1 squared. That's +1. That's why I have a +1 here. Then here, after I factor out -9 from these two, when I complete, because it's easy to complete square when the leading term has a coefficient of 1.
Yeah.
So I pulled -9. When I take half -4 is -2. If I square it, I get 4.
So you do -9.
But -9 times 4 is -36. So I have all that 71 plus 1 minus 36, which becomes 36. And it helps makes the map clean when you divide by 36, because then you have a perfect square. So you can easily figure out what A and B are.
Okay.
Yep. Okay.
And then it's x minus 1 squared over 36.
Yep.
Yeah. Sorry, I wasn't really locked in when you were doing that. How do
No
you
worries.
get 36?
How do I get what? Sorry.
Why is it over 36?
Because I divided everything by 36.
Oh yeah. Okay.
because you want 1 on the right side. Okay. So now let me look at some other
Mr. E?
questions here. Yeah, go ahead. Mhm.
You said you could tell right away by the negative in the equation.
Yes, the
what
negative
negative you
next to y
refer to?
squared.
Negative. Okay.
Yep.
All right. Thank you.
Yeah, because that's gonna it's gonna wind up looking like a minus in the middle. Okay. Okay, so let's do 39. Okay, and then 29, 39, 29, and then composites. Okay. Oh, and someone's asking again. Let me look at the timestamp here. This is just sent. How do I know if it's just x squared is positive, horizontal? If y squared is positive, vertical. In your formula sheet, that's how you know. The formula sheet shows you right there. X squared is positive, horizontal. Y squared is positive, vertical. It's all on your formula sheet. Okay, so let's do 29 next. Sorry, 39, and then 29. Okay, 39. So I'm going to have you guys graph a piecewise function. I did say this in class. It won't be as, this one's a little too much. I think I changed it to x minus 1. But the question is about increasing, decreasing. So let me just kind of go straight to the solution key and then show you how to tell whether it's increasing, decreasing. Then I'll do 29 next. Okay, so here's the graph. I changed it to x minus 1, the bottom one, because that's just a little too much the way it is right now. So here's the deal. You're always going to be increasing when the graph is going up, right? I mean, that's just what it means. How do you mean, what do you mean by going up, right? You always start over here and you move to the right. As I'm moving to the right, the graph is dropping. Another way to think about it too, it's like a slope. It's a slope negative. You're decreasing. And then all of a sudden you start increasing after x equals -4. Was that -4? I'm sorry, -3, that's what I'm saying. And then it keeps increasing over here, then it decreases. So let me color code. I'll let green be increase, red be decrease. So that's all decreasing. And that's decreasing as well. These are all increasing. Those are increasing. So you can look at here we go. Let me zoom out.
And then Mr. E, for the when you have like that type of graph, it's a filled in circle when it's greater than
Equals, yes. And if it's not, don't include it, right? Don't include it. Yeah, piecewise functions are a big deal in calculus too. Actually, I kind of wish we did piecewise functions in the fall and then just reinforce that the year. We are going to realign pre-calculus because we just feel doing so much trading in the fall just doesn't make too much sense. But anyway, so it's increasing clear from -3 to -1. Let's go green. And -1 to 0, and of course 3 to infinity. Then decreasing from -infinity to -3, and from 0 to 3. That's where it's
And
decreasing.
could we kind of go over like, I don't know,
And then like also with the brackets or parentheses, how does that work with this? Because like
if it's included, bracket, parentheses not included, just like interval notation we've always done. Brackets included, parentheses, because the parentheses looks rounded, right? And usually, we put like a circle when we saw included, and then the bracket means it's included. So wait, JP had a question. What was your question?
yeah. Could we just kind of like, I don't know, like where would you start?
Yeah,
when you
we can walk through this one. Let me hit up 29 really quick, and I'll come back to this again. I can do it from scratch. Let's look at 29. Someone asked about 29. Because I know some people probably want to get to bed and been waiting for some of the questions to be answered. Okay, this is back to transformations again. So, you have to describe, okay, and graph it. Yeah, so this is clearly 5 right. Vertical stretch by 2. Reflect about x-axis. And shift 3 up.
And why does it reflect about the x-axis? Because it's -2?
Yep, the negative right there. Okay. So cube looks like this. So if I shift 5 right and 3 up, I'm gonna be at 5, 3, I think. 1, 2.
And the 3 on the outside, like whatever that number is, all that changes. Is it shifts up by 3, or for B, it shifts down by 1?
Right.
Okay.
And then the negative means you flip and also get stretched. So, I mean, if you were to make a table, I suppose, like for the original graph function, they're putting like 1, I get 1, -1, I get -1, right? 0, I get 0. So for the new graph, what's happening here? Multiply by -2 and 3 up. Multiply by -2 and 3 up. Multiply by -2 but 3 up. And of course, add 5. So it's 6, 4, and 5. So we're at 5, 3. So you have 6, 1 and 5, 3. Sorry, 4, 5. So the graph kind of looks like this. Domain's going to be all real for cubes, and likewise the range. For B, you're shifting 2 left and 1 down. So you get -2, so 2 left, 1 down, but also your vertical stretch by 3.
Wait, I thought if it's a vertical stretch only if the leading coefficient is negative.
No, that's reflection. Remember, the negative means you're pointing down now, or you're flipping over.
Oh, so if it's negative, that means a reflection?
Yeah, totally. Yep.
Okay. And so
the 3 is kind of like when the number's not 1 over here, that's kind of more like a slope in a way.
So regardless, it's kind of always a vertical stretch.
Yep.
Mr. E?
Yeah, go ahead.
So I know like when it's negative in the front, it reflects about the x-axis.
Yes.
But since like for B, since there's a -1 at the end, would that mean
that's just shifting
it's
1 down?
It's just shift.
That's
there's no reflection on that.
0. You're
Okay.
not multiplying. Remember, the reason why think numerically, don't memorize. Think numerically what's happening. If you're multiplying the function by a negative on the outside, all the y values become negative. They're all going down below that. So that causes a reflection.
Okay.
But anyway, I have -2 and -1 as a endpoint, and then if I were to plug in, like, say, -1, for example, I should get 2. If I plug in 0 or a 2, for example, I should get 5. Yeah, so graph looks like that. So domain's obviously going to be -2 to 0. Sorry, to infinity, my bad. And the range is going to be from -1 to infinity. So that's 29. So it's more on
and if it's cubed, it's negative infinity, positive infinity for both.
Right.
And if it's squared, what is it?
Well, I mean, if it's squared, the range will be, the domain will be all real, but the range will be depending on the vertex. Like if it's pointing, you want to find the y-coordinate of the vertex. I mean, the graph is going to tell you, right? Like if you have like y equals x squared plus 2, for example, right? I know my vertex at 0, 2, and you're pointing up. What do you think the range would be for this?
Positive infinity, positive infinity.
No, because what's the lowest y coordinate?
2.
Exactly. It doesn't go below 2.
Oh, so 2 comma positive infinity.
Exactly. Right.
Okay.
Right. Okay.
I'm just a bit confused, at least on A, how I
Mhm.
understand like you go 5 to the right and then
Mhm,
3 up.
mhm,
but
mhm.
When it comes to the vertical stretch.
Well, I'll do that
How
again
you-
because I did that a little quickly.
Okay.
I'll do it again. And then the parent function is always just going to be what it is without all the other junk connected to it. So like the parent function is y equals x cubed, which actually that will help you, Gigi, with explain the vertical stretch. The parent function is just that, right? The parent function is just the most basic function, right? The most basic function doesn't have that. Like doesn't have the a, h, or k stuff. So let's do a table, right, for this stuff here. If I do it for the parent function, like if I plug in 0, I get 0, plug in 1, I get 1, plug in -1, I get -1. Now if you look at the transformations, because I shifted 5 right, I'm adding 5 to the x coordinates, right? So I have 5, 6, and 4. The -2, the vertical stretch means you multiply by -2 and then add 3. Right? Because that's what the -2 does. It multiplies y by -2. If you had just y equals -2x cubed, then that's what would happen, right? All the y values would be multiplied by -2. But the +3 means you're also going to add 3 afterwards. And it's PEMDAS, right? You multiply before you add. So that will be 3. That will be 1, I think. And that'll be 5. So that's how you get that. 5 3s right here. 6 1s right here. 4 5s right there. That's how I got those points.
So you do a table and then you flip the x's and y's
Yep.
for parent function.
Well, you don't flip the x's and y's, but you change the x's and y's. And you change it based upon the transformations. If you're for example, if you're going up or down, you're changing y, right? If you're reflecting about the x-axis or stretching it, also you're changing y.
Yeah.
But if you're
and
moving left to right, then you're changing x.
why did you choose 5 6 4 for your x's?
I didn't choose 5 6 4. I altered it based upon going 5 right.
Oh, okay.
I
so
added 5 to these here.
You're plugging in 0, 1, -1.
Into the parent function, because those are easy numbers to plug into the parent function. And then I make an adjustment based upon the transformations in the equation.
Okay. So for
That's
the
all I'm
y
doing.
value,
Right.
so you're adding 3 and then you're subtracting 2.
Right.
Okay. And then you're adding 5.
Well, we'll multiply with -2, then adding 3 after that, because it's PEMDAS.
Yeah. Okay. So then, just sorry, I know I'm asking.
No,
a lot of
that's okay.
questions.
That's good. I just want to make sure I'm getting
But
all the yeah, keep going.
doing 0. So if I get something like that, you plug in or 0, -1, and 1, and then whatever numbers you get for that, you
Mhm.
just then based off the equation adjust.
Yes. Yes.
And then graph that
yes.
the adjustments. Okay.
Yes. Okay. Hold on. I kind of lost track. So let me talk about composite functions. I know Luke, you're asking about 35. Actually, is Lucas still here? Hold on. You are still here, Luca. Okay. All right. I'll do it. Don't worry. Okay. So back to sharing my screen again. Okay. I do want to talk about 30 though. I think 30 is a really good one. And Anthony, great question. Actually, let me do 30 right now. And then I'll do 29. Then I'll talk about 35 again. And then oh, and then yeah, yes. Well, this was about 15 minutes ago, but yes, piecewise functions are going to be on the test. And we just talked about, I can talk about how to graph those again. So let me start with 30, then let me talk about how to graph piecewise. I'll do composites, and then I'll see if I do 35, and then we'll drop the call in about 20 minutes from now. So how to write the equation of the problem with vertex 2, -7. So plot the points though, like 2, -7s right here. 4, 5, 6. Guys, that's so sloppy. Sorry about that. Okay, you know what? Let me do it better. Let me do it better. 1, 2. 1, 2, 3, 4, 5, 6, 7. Okay. Two -7, 2 -5. Okay. So it's going to open up because the focus is always inside the problem. So it's going to open like this. It's not going to be a super accurate sketch, but I know it's going to be a vertical parabola. So now I go to my formula sheet. It's okay, parabola. Its vertical is opening up. And that's the form 4py minus k x minus h squared. And p is simply the distance from the vertex to the focus. So in this case, my p value is just going to be 2, right? P is 2. And again, the formula says 4p.
Do we get this formula?
Totally. Yeah, I just showed it to you. Yeah, it's right here. Right there. 4p y minus k equals x minus h squared. And p is 2, so just plug it in, you get 8. And then the vertex is at -2, sorry, 2, -7, so it would be y plus 7. And equals x minus 2 squared. That's it.
Mr. Onwashi, I think that the formula sheet you gave us is different than the one.
Yeah, I'm giving you guys the one that has the p in it.
Okay, cool.
Yeah, I made that update on Thursday night. So, and actually, the one in School G is updated also. I hope it is. Let's find out. But I'll give you guys yeah, because the A1 just seems too weird. Like it's not the way I teach it. And I don't like it.
Mr. E,
Good.
for number 30, I have a different equation than that.
What's your equation?
I have y equals
Oops.
2 times x minus 2 squared minus 7.
Sorry, repeat it one more time.
Y equals 2, and then in parentheses, x minus 2 squared minus 7.
But it has to be 4p though. It should be y equals
Because I thought, so the
wait.
equation for parabola, isn't it? Well, 4a times x minus h squared.
I'm not using that a form, but even if you use it, you should still got the same equation though. I prefer you don't use the 4a one.
Oh.
I mean, you could. So the equation was this: is 1 over. So it was y minus k. So we're using this formula, Charlotte. Or sorry, did it look more like this? Did it look like this? Your formula: y equals 1 over 4a x minus a squared plus k.
That's what it should look like.
No, is that what you were using?
I just had a times x minus h squared plus k.
Okay. Oh, I see. Okay, but what they're saying is that okay. So that's what you're using.
Yes.
Okay. The problem with that formula is you need another point on the parabola to solve for a. So you have to use a formula instead that helps you figure out what that allows you to plug in for the distance between the vertex and the focus. So that doesn't really help you because you don't know another point on the curve. That's why it's better.
The 2 and the -5 aren't on the curve.
Yeah, exactly. Right.
Okay.
So that's good. Okay, that clears up the confusion. That's good. But anyway, the formula sheet that I have here. Let's make sure it's updated.
Oh, so that's why you plug in the
Right.
first numbers, not
Right.
the 2, -5. Because
Exactly.
It's not on the curve.
Yes, exactly.
Oh, okay, sweet.
It's not on the curve, right? Okay, so that's okay. So that's good because I'm going to have something like that in the final too. So I want to make sure we had that discussion. Okay, hold on, just totally. Yeah, let's talk about piecewise. Okay, so everyone's out. So a couple people asked about piecewise, and let's look at 19. They asked about 19. I don't know what 19 is about. Because piecewise will do. If not, I'll choose another one that's piecewise. Okay, so Leah, I did do 19 earlier tonight. I mean, I'll stick around a little bit later. And 35, I know Luke is still asking about that one too. So any problems I have done, I want to just prioritize ones that haven't been asked, but I'll still go over those again. But remember, I do have a recording of this, and I will share the recording with you guys after we're done tonight. But I'll still go over it anyway because I know you're asking about it. But you figured it out. Okay, great, awesome. Yeah, just multiply the bottom by 2 and then subtract the equations, and then the y squares will cancel. And then the solution key should show you how that goes. And the solution key is up in school, and I emailed them Friday. Okay, piecewise, let's talk about that because I know that's on people's minds. All right, so
Is this gonna be tomorrow or
Yep.
Wednesday?
yep,
Tomorrow? Okay.
tomorrow, yep. No, wait. No, that's gonna be on Wednesday.
Oh,
Um,
okay.
Hold on a sec. I could tell you for
That's
sure.
on Wednesday. You're having another Zoom on Tuesday, right?
Not Zoom, actually in person.
Oh, okay.
I mean, if you want to be on Zoom, I'll pull Zoom open. But it's after, it's like during X period and office hours and after school.
Okay.
So hold on a sec. Let me look at the final really fast here. So part 2. Yeah, the piecewise is Wednesday. But let's talk about it because you guys are asking about it. Okay. So let's look at this one here. How do you construct the piecewise? And then how do you analyze afterwards? So remember, I didn't like this one. I made x minus 1 because that just seems a little too weird. So this one, is a V shape, right? So absolute of x, and it does involve transformations. You got to know it shifts 3 left. So instead of so absolute of x looks like that. So you're going 3 left, so you're starting over here. Because if you plug in -3 for x, you do get y0. You're not going to go 3 right, because if you plug in 3 for x, then it's going to be 6, right? Not 0. And then you can plug in -2, for example, you get 1. Plug in -1, you get 2. Plug in 0, you get 3. Plug in -4, you get 1. Plug in -5, you get 2. Plug in -6, you get 3. So you got a V shape here. However, its x is less than -1. So really you only want to start at -1. It's not included, so it's a whole. You got that. That's the first piece. The second piece is a parabola. We know what x squared looks like. X squared is simply a parabola that opens up, and the vertex is at the origin. We know that. That's y equals x squared. However, we're flipping over with a negative in front, and we're adding 2. So when you flip it, it looks like this. When we add 2, it gets shifted up 2 units. Now you're starting at -1, which makes it +1 when you plug a -1 in for x. I'll do a different color here. It's not included. There's a point at 0, 2. And if I plug in 3, I think I get -7. Plug in 1, I get -1. Plug in 2, I get -2. Plug in 3, I get way down here. So there you go. And actually another hole again, because it's not included. And if I plug in x minus 1, I know the graph y equals x minus 1 is just a line like that. But if I plug in 3, I get 2. That's correct. And then just a line. There you go. So it's pretty clear the domain is not all real numbers because I have some gaps at -1 and 3. So you just gotta make sure you exclude -1 and 3 from your domain. That should be a real easy question. Oh, I meant to put 3. The range is also pretty easy. That's just look at the y values. The lowest y value is -7, but it's not included. And the highest y value just goes up forever. So there's your range. X-intercepts where it crosses the x-axis, included at -3. So -3, 0. But this one, the parabola, you have to set the parabola equal to 0. That's not hard. Just do that and just solve. 2 equals x squared. X is √2, plus or minus √2. But it's obviously going to be positive √2, so that's another x-intercept. Relative means when you switch from decrease to increase. When that happens, that definitely happens at -3, 0. And that's it. You switch from increase to decrease as a relative max, that happens at 0, 2. We already talked about increasing and decreasing. We did that earlier. It's kind of like if you have a negative slope, it's decreasing. If you have a positive slope, it's increasing. So it's decreasing from -3 to -3 and from 0 to 3. And then it's increasing from -3 to -1, from -1 to 0, and of course from 3 to infinity. That's where it's increasing. And the solution key should show that right there. Lastly, y-intercept 0, 2, that's pretty obvious. Never constant. The -20, just plug in, when x is -20, you're going to plug into the absolute value. You get 17. F -1's undefined because we didn't have anything defined for it. And then F4, plug into the last one. So I think hopefully that takes care of piecewise. Hopefully it makes you guys feel a little better about that. And again, we do more practice on Tuesday too, because that's not going to be until Wednesday. Let's see.
I'm about to leave, but are there any like the gas Jordan method? I kind of forget what those are called. Are there any of those tomorrow?
Wait a sec here.
I thought that was
I think it's Wednesday.
okay. Just
Hold
making sure.
on, no. Let me confirm it. Because most of the matrices stuff is going to be on yeah, it's Wednesdays because that's going to be basic calculus. Yeah, that's Wednesday.
Okay. All right, my man. Thank you so much.
Yeah,
for
you're
this.
welcome. Yep, no
Feel
problem.
better.
Okay.
Mr. E,
Yes, go ahead.
is there anything like related to matrices tomorrow, or is it just all on Wednesday?
Just determinants, and you have a calculator for that one.
Okay, perfect. And did you say is that one you can just enter it in the calculator?
Totally.
Can you
Yeah.
show us how to do that?
Yeah. And again, like if you were to go to well, I mean, you have to kind of scour through my videos. I guess I'll just show you right now. It's easier that way. I mean, you could do it by hand too tomorrow if you want, but let me show you how to do in the calculator. And hold on, I just want to make sure there was another question. I just want to make sure I'm taking care of everybody here. I know Damien even asked. Damien's okay. Let me do composites really quickly, then I'll show you how to do the calculator for the determinants, and then Luke at 35. I'll talk about 35. I know you've been waiting.
Mr. I saw your email. You said something about how we can't use our own calculators, that you're giving them to us.
Yeah, so I'm gonna so the graphing calculator, I will provide it. The only reason why is because I do have to clear the memories afterwards because there's also Mrs. Sui's E, F, and G periods that take it on Tuesday and Thursday. Not that I don't trust you guys, but I do have to play it safe because I can't have it bite me in the ass after like I don't want to be called into the principal's office like people are sharing answers about the final exam and we have these school use calculators for that. So because I am going to because usually when we give tested, they're usually given like on the same day, but because it's the final exam, it's high stakes. I have to clear the memories of the people in my classroom. I don't think the AC is capable of doing that because I don't think they know the calculator very well. That's why I'm going to provide the calculator for you. Unless is there something you really need on your own calculator that would
No, I
matter
was
to you?
just curious.
Okay, I mean, if there's something you really need, then I could always put that program on there for you. But if it's nothing, yeah. But remember, I'm giving you a formula sheet. Like I'm giving you everything you need formula-wise, so it's not. There's something like number 2 in the test tomorrow. Let me ask. Gigi's asking about that right now. Number 2. Let's talk about it because Dan was asking about that. That's I think. Let me stop sharing one more time. Hold on. I think that's also. Actually, that could be there tomorrow. Yeah. So let's talk about that. Let me go back to sharing one more time. Okay. So yeah, so number 2, I mean, you don't need a calculator for it, we just put it in there because it just fit. But composite is real easy. So when you see this here, that's G of F of X. So Dan, we'll get into your question now. So yeah, just plug in F into the G function. So instead of root X minus 3, you have root X cubed minus 1 minus 3. So you're replacing this with F. And then you could clean it up. It's root X cubed minus 4. The domain, you have to make sure anything inside a radical stays positive or equals 0. So X has to be greater than or equal to the cube root of 4. So cube root of 4 on 0, and there you go. That's or the other one like F over G. I mean, that's easy. Just do one over the other. the domain you can't divide by 0, and because it's a radical, it's got to stay positive. That's why it's from 3 to infinity. Or for a, that's easy, just subtracting two functions. It's x cubed minus 1 minus parentheses negative 7x plus 4, and just clean it up. Not hard. X cubed plus 7x minus 5, I think. That means we all real because it's just a polynomial function. So, question in chat. I'm providing graphing calculus for those in ASC, not for you guys. That's in the ASC. Because in our classroom, I could clear the calculus because I know how to do that. It's the ASC where I think because they're managing so much and not everyone in there knows the calculator well enough. I mean, if there's a math teacher, maybe they would, but I'm just going to provide the graphic calculus for the ASC tomorrow. But if not ASC, yes, bring your own. I might have some if you happen to forget, but that just kind of puts me in a bind. If like 10 people are asking, then I don't have 10. So
So will you have 4-function calculators?
that I will do. I mean, you don't need it, but if you want it, we'll have that for sure. The graphic calculus is always kind of tricky. That's just those seem to grew a pair of legs and just walked off. We had like I think 150 like 10 years ago, and there's a history behind it. I don't have to get into the whole history, but there was a big cheating scandal that happened in AP Chem, and ever since then we felt like we have to have do something about the graphic calculus. Then we had the pandemic, right? And that changed things. But anyway, I don't want to talk you guys here off about history of cheating. Okay, so we took care of number 2. Juju's asked about that, and composite Damon asked about that. Let's see here. Okay, so all right, 35. Let me do that really quickly. And then I think we're going to wrap up this call very shortly.
Thank you, Mr. E. See you tomorrow.
Welcome. No problem. Yeah, so average rate change, that all you gotta do is just f of -1 minus f of -4 over -1 minus -4, or you can reverse it. That's all you gotta do. You plug in -1 to this function, which I don't know what that is. Plugging -4, I don't know what that is either. But if you do that, I think you get -570. And down below you get 3, and divide you get -190. That's all. Just plug -1 to that function, plug -4, take the difference. And what's happening is that you're getting a funky curve, and it's finding the slope between 2 points. We call an average rate change because on average, how does the slope change between those 2 points? It's kind of like if you're driving from here to LA or from the Bay to LA, and like, okay, like it's 400 miles, and it takes you 5 hours on average, you're driving 80 miles per hour. Not you drive 80 miles per hour the entire way, but on average, that's what you do. Okay. And trying to see if there's anything else. I think I tackled all the questions. Anything burning before I end the call that you guys want to really ask about? And again, I'll be available. Actually, I am on campus tomorrow during A period, so if you have free A. I'm an on-call sub. But I think what I'll do is I'll just kind of just post up. Probably just post up my classroom. So if you just peek your head in during A period, unless I'm subbing, then I might have to go because I'm on-call sub. But if you peek your head in, and then of course I'll be available during lunch, and I'm gonna this recording might take a little while to download. It's a pretty long video and upload to YouTube, but once I get the link going, I'll share it, and the link should be live in a half hour from now. But please sleep. Don't stay up till 1 or 2 in the morning. Don't do that to yourself. You need about, I mean, school starts 8:30. If you have free period, great. But if you gotta be on campus by 8:30, you gotta leave house by 8. Probably be up at 7 in the morning. Make sure you get 8 hours of sleep. So don't, be in bed by 11, right? So don't do that to yourself, and you don't need to pull all night, or all night are crazy. Okay, anything else before I sign off here? Oh, the calculator. Yeah, sorry. I knew I was forgetting something. That's right. Again, you could do it by hand, but yes, thank you, Dan, for reminding me. I knew I was forgetting something. Okay, math department. Yeah, here's how I do it. It's really easy. And again, I know I did it with you guys, but it's been a while, and I know it's in one of my videos, but I'll just see if I show it to you here. And I mean, obviously, you could always just YouTube whatever, and it'll show up on, everything's on YouTube these days, right? But really easy. Let's say you have a matrix. Like, let's say I'm just going to totally make one up. So first you have to enter the matrix. So you have to hit, and it says matrix in the calculator. So if you don't know where it is, I'm just going to tell you, just find where it says matrix. So second x negative 1, and then you have to edit it. So you have to make one up. So I'm going to make one up. I'll do a 3 by 3. I'll just put some random numbers here.
Is the one on the test going to be a 3 by 3, or do we not know yet?
Yeah.
Okay.
Okay. I mean, actually, the way to do it is also shown in the formula sheet too, just so you know. And then you're just gonna once you do that, then you hit math. Sorry, hit second matrix, hit the math menu, and then determinants right there. And then hit second matrix, call up the matrix you just entered, and there you go, because you did a determinant. Or you can do this.
Is it like with a graph where you can't put in like minus and then the number you need to put in the special negative one?
Yes, exactly, because it'll freak out. Exactly. Or you can do this. You hit second matrix, and then if you hit alpha zoom, you can actually type in your own matrix right there as a shortcut. So I do a 3 by 3, and then you just type in the numbers. It's like 1. You have to hit the right key, though. It's kind of annoying. Again, totally making these numbers up. Yeah, there you go. That's it. That's either in the calculator. Okay, well, this is getting kind of late. Let's go ahead and stop sharing. So yeah, I'll stop the recording. Should be available. The link should be available on Schoology in the next 20 minutes. And I think that's that. Any other questions? See here. Oh, you're welcome. No problem. Yeah, my pleasure.
Thank you, Mr. E.
Hopefully you guys found this helpful. And then
Thank
I'll see you
you.
guys on campus tomorrow. Okay,
Thank
great.
you.
Have a good
Thank
one.
you.
All right, see ya. Bye.